Good day to you guys. I'm sharing this video with you because the way things have turned out today, our meeting tonight's not going to be doable. Long story. I apologize because we haven't been able to do that yet. The way things worked out with the holiday last week and so forth. So this video will go over the basics. I'm going to talk about some of the nuances of identifying igneous and metamorphic rocks to augment what you're going to see, of course, in the basic material. And then, of course, I'm going to make myself available tomorrow at 8:30, which I know still won't be convenient for everybody, but I'm trying to make the effort here to on Zoom to be available to you guys. So it'll be the same Zoom link. I'll send it out here with this announcement. So, all right, so let's dive into it. This week we're going to be looking at crystalline rocks, and I kind of merged these together with because it kind of makes sense to some extent, even though I could do it differently. But basically, we're going to be looking at igneous rocks and metamorphic rocks. If you've had earth science in the past, you've had some introduction to this. My hope is that whatever that even a littlest little bit of introduction you've had to before will help access some prior knowledge for you. I've also stuck in here the topic of volcanism. This one's not as in depth. There is a lab for you to do with that. There's a lab for all three of these, but I don't think they'll take you as long as the virtual field experiences can. And so, again, everything should be submitted as PDFs because that's the way that Canvas best views all of this. Unless I say otherwise, spreadsheets, those should be viewable just fine as well. But of course, you'll have your introductory material. So here's your introduction to igneous rocks, your introduction to volcanology, and your introduction to metamorphic rocks. I don't require you to do these in any particular order. You can go and read through all those if you want. You can, of course, go and do the igneous rock introduction, then dive into the lab, and then take the quiz. And all of that might take you just a couple of hours. If we look at the lab here, basically you're going to be looking at a virtual sample set of igneous rocks, and using this chart here, you're going to identify them as best you can. You've done this before with the minerals, although the mineral one was a little bit different. Basically, I want you to create a chart where you identify the name, but really give me the texture and the composition. When I say that, the textures are down here, so it's going to be one of these, anything from pyroclastic up to coarse grain phaneritic texture, and then the mineral compositions are going to be one of these four. Once you've identified those with igneous rocks, it's just a matter of figuring out which named rock is in that chart. This is one identification scheme. There's actually a much more detailed chemical identification scheme, but we're not going to get into that. That's it's a bit more advanced. So this is your basic scheme here. So if we go back to the prior page here, this lab here should come to you as a Google document that you can then just print out or just type right into. Okay, and it gives you some background. Basically, it's a look at the 1980 Mount St. Helens eruption, and gives you a lot of background with that. It actually tells you what you need to do here, but you need to print this document off, this graph, okay, which comes up right there, and you'll need the topographic maps, which I may have to fix that. Hopefully this second one should open it up. Yeah, there we go. So the first link doesn't work. I'll delete that, but the second one does. These are the maps you need, and you're going to create a topographic profile here. Now, creating a topographic profile is just a matter of laying your graph along the line from A to A prime and then B to B prime. You're going to make both graphs on the same, you're going to make both profiles on the same graph. So you'll want to print all three of these papers off to do it. It'd be tough to do it online, but you could do it, but it'd be tough. Okay, and then when you do that, you lay the paper across here, and you make a tick mark for every single little contour line, making note of the elevations of the contour lines. The contour interval here is 100 meters. Okay, and again, I'm relying on the fact that you've seen topographic maps before, and most of you have. Generally, that's not as much of an issue, but if you need more additional help on that, let me know, or do a little Googling around. It's amazing what you find on YouTube, of course, to help out with that stuff. But I will... I do have access to a video on YouTube that does a decent job with creating topographic profiles, and so I can post that here as well. But anyway, you're going to lay your paper across here, make little tick marks, and then you simply, across the top of this, and then you transfer those down. So if you made a tick mark for 3,000 meters, you'll make a dot there. Make a tick mark here for 2,500, you'll make a dot there. pretty soon, what you're going to end up with is a volcano. This profile is going to look like a volcano. This is the bottom, and then the peak would be up here around 2900. B to B prime is going to look very different because when Mount St. Helens erupted in 1980, it blew off half the mountain, and it blew out laterally, and so it was a very different different eruption. Okay, that won't actually take you that long once you figure out what you're doing. Oh, there's the video on drawing a profile, so you can check that out there. Okay. All right, so if we go back one more time here, there's one more lab for you to think about, and that is when you get down to metamorphic rocks, which are the rocks that form primarily under heat and pressure. And again, you're doing exactly the same thing as you did with the igneous rocks. You're going to go to the sample set, and then you're going to go look at the chart. The chart, you click on that link, and if it doesn't pop up right away, it's in your textbook. Oh, there it is. With metamorphic rocks, it's primarily identifying them first as either foliated or non-foliated. And you'll understand that better once you go through it. Basically, though, foliated metamorphic rocks have what looks like a bit of a layered texture, and non-foliated, you don't see any real layers. And so then you go from there. You just look at the textural features. You probably aren't going to do much mineral identification, to be honest with you, and then give it a name. Okay, and so that's just really practice at it. I don't expect you to be an expert at this rock identification. What I want you to be is conversant in how to use these kinds of charts, how to tease out using your observation skills, what you think the right identification is, and go from there. So I'm not actually as concerned about you getting every rock correct. I'm not there to help you with that, right? So that's something that my expectations have to be different in an online environment than they are in a lab environment in person. So here they are. Then take your quizzes, and you're good to go. All right. So briefly, I wanted to share with you a couple of rock specimens. This by the way, it's Sketchfab. If you go and look at sketchfab.com and just do a search for, say, any igneous rock, you'll find examples. This is a granite that somebody made a 3D model of, and you can see the different mineral grains. This texture in igneous rocks is called phaneritic. It's a coarse texture. You can see the mineral grains really, really well. And in an aphanitic texture, you wouldn't see the mineral grains very well. And so that's a little bit different. So if I pick an aphanitic rock, like say an andesite, we can zoom in on one of those. Actually, sometimes with andesites you get what's called a porphyry, but let's look at this one. Okay, once it loads here. So this one you can see the mineral grains, but the ground mass, the bulk of the rock, is actually very fine grained. So like the grains are less than 2 millimeters across. You have these large, what are called phenocrysts, that kind of sit in the sea of grains. It's kind of like, I don't know, think about a salad. No, it's not really a good way of putting it. Think about a couscous salad with corn all throughout it, right? So the little corn kernels are bigger. And so you can see the gray ground mass. You can also see the plagioclase phenocrysts and then hornblende phenocrysts. So phenocryst is a term that basically describes that this rock had 2 periods of cooling. Though the texture here is not actually aphanitic, it's porphyritic. And what that means is you've had 2 periods of cooling. You had a period where the magma was cooling inside and the crystals were growing large, and then it erupted, and the ground mass cooled quickly, and that's what's going on there. But again, all this is talked about in the background material, and you'll be seeing samples like this. But again, you just do the best you can. Again, these virtual samples are not ideal for this, but they're better than nothing. So you may have to look closely. And again, some of these are hard to see. If you go back to I didn't use much of the way of 3D models for the sample sets here. So if we go back to the original sample set, for instance, let's look at the igneous rock sample, igneous rock lab, and look at the sample set. Most of them will be gigapans, and the detail is much, much clearer than it is on the others. So we'll wait for this to load. It's a little slow here. Some of them tend to be a little dark as well. Let's take this one, for instance. All right, so we'll go ahead and make this one bigger. Note that you can take measurements here, which is very useful. If you make a Gigamacro account, which is free, then you can actually take measurements. There'll be a little ruler that'll show up and you can measure things. But you can see if I zoom in on this, I can see some incredible detail. And so this rock is, it's a porphyritic texture again, right? Because I've got this sea of minerals that I can't see how big they are, and then I've got all these little phenocrysts of other things. But these, if you have questions, let me know. But here's an example of a piece. This part doesn't really belong in the rest of this rock, right? It's a big chunk of essentially basalt. You might make an argument for gabbro. That was lodged within this magma that the result of this came out of. So there's a story to each of these rocks. So this stuff was cooling. This stuff was placed inside this other magma at one point, and this magma had two cooling periods as well. So that's pretty interesting stuff. If I want to look at a foliated metamorphic rock to show you an idea what foliation looks like, let's look at well, gneiss is the sort of classic here. If you look at a gneiss, don't take gneiss for granted. All right, so here you have you can see the banding of minerals, and that's an example of foliation. You got quartz and feldspar here, and then on top you've got some biotite that you can see, some flakes, those little shiny flakes. But if we look in here nicely, you can see bands of minerals. So what happens during pressure and temperature, the pressure was being applied from the top of the specimen and the bottom of the specimen to squeeze it together, and that caused the mineral bands to be formed. So what used to be a granite, where the minerals are spread throughout evenly, became a gneiss because of the pressure, and was foliated. Now, a non-foliated metamorphic rock, that is one we should go and take a look at as well. Marble is a good example. And marble is a good example because marble can be a, let's see if I can find one that's not a statue. Um, well, somebody's had some fun with 3D models here of classical stuff. It's fun to look at. All right, marble, I don't specimen. All right, well, here we go. So here's, let's go with this one. This one you can see looks like it has foliation in it, but it's not actually foliation. You gotta be careful with marble. That's what I was getting at. Marble, actually, this is, I hope this is what I think it is. Yeah, this is marble. So marble is metamorphosed limestone. And you can see there's stuff in here. It almost looks like banding, but it's not banding. And it's really important to note that this is not banding. This is just impurities that, they can turn into swirls and other things, but the grains in this are interlocked with one another. They're not actually in mineral bands. And that's important. So, okay. So anyway, how do we get metamorphic rocks? We get them primarily through heat pressure and then hydrothermal interactions with fluids in the ground. Okay. So if we go back to our original modules here, I will get to the first thing I'm going to grade for module 1 is going to be the final paper stuff, so that you have some feedback on that. I'll try to get to that in the next day or so. Notice you don't have anything for that in the second week. I do want you to continue thinking about that, because in week 3 you are going to have a couple of assignments related to that. Week 7 you'll have the whole thing due, so be looking at that. I will begin adding more dates for subsequent modules, but for now, just know that everything for any module is going to be due that Sunday night at midnight. And so the dates are all going to be every week, Sunday at midnight. That's generally how that works, to keep it simple. Okay? Again, if you have questions, let me know. And maybe I'll see some of you tomorrow night at 8:30. So it'll be tomorrow, Tuesday, January 26th at 8:30. All right. Take care, guys.